In this example, we'll graph the square root function y equals 4 minus 1/2 times the square root of 2x plus 3. So the first thing we can do is we can rearrange or slightly alter this equation so that it's easier to see what transformations have taken place. So we can write this as y equals -1/2 times the square root. If we take the 2 out, we get x plus 3 on 2, and then we've still got our plus 4 there. So with this in mind, we can now look at our transformations. So the first thing we can notice is that it's been dilated by a factor of 1/2 from the x-axis, and that's that half there. It's also been dilated by a factor of √2 from the x-axis, and that's because we can actually take out the √2 there as being multiplied by the square root of x plus 2 on 3. Then we can see that it's been reflected in the x-axis, and that's because of the negative sign out the front. We can see that it's been translated 2 on 3, or 1.5 units in the negative x direction, and that's because of the x plus 3 on 2 right here. So if we take the 0 of that bracket, we get -3 on 2. Then if we... And finally, it's been translated 4 units in the positive y direction, which we can see from the positive 4 value there. So next we can find the y-intercept, if there is one. So to find the y-intercept, we have the y-intercept occurs when x equals 0. So when x equals 0, we have y equals 4 minus 1/2 times the square root of 2 times 0 plus 3. Therefore, y equals 4 minus 1 on 2 times the square root of 3. And that gives the y-intercept at x equals 0, y equals 4 minus √3 on 2. Next, we can look for the x-intercept. So the x-intercept occurs when y equals 0. So we're going to have 0 is equal to 4 minus 1 on 2 bracket 2x plus 3. Then once we've done that, we can add 1/2 root 2x plus 3 to both sides. So we're going to have 4 is equal to 1/2 bracket 2x plus 3 times both sides by 2, and we get 8 is equal to square root of 2x plus 3. Then if we square both sides, so square that side and square that side, we find that 64 is equal to 2x plus 3. Subtracting 3 from both sides, we have 2x is equal to 61. And finally, if we divide both sides by 2, we will get x is equal to 61 on 2. So this will give us the point 61 on 2, which is 30.5, comma, y is 0. So if we use all this information, we can begin to graph our square root function. So we've got the point 30.5, comma 0 as the x-intercept. The y-intercept is 4 minus √3 on 2, which is somewhere around there. And then taking into account how our transformations have occurred, we also know that we have the point -4. We have the point -3 on 2 due to the x translation, and we have the y is +4 due to the 4 units in the positive y direction translation. Putting our square root function through these points, that is the graph of y equals 4 minus 1/2 times 2x plus 3 square root. So the last slide was getting a little bit cramped, so here's a computer generated graph of the function y, and you can see the starting point is at x negative 1.5, y is 4, goes to the y-intercept of 0, 4 negative root 3 on 2, and finally goes to the x-intercept at 30.5.